Welcome to the factory tour at Lisa. Hohenwestedt is the biggest manufacturing facility for safety valves in Europe. We show you how we build quality into every valve we make with our passion for technology.
What is unique about production technology at Lisa from your point of view?
We have not only a modern machine tool fleet, but also the most effective production concepts in our industry. In the last few years, we invested more than 15 million euros in machines and processes. And here you see one part of this highly automated production. On this machine, nozzles are manufactured in series production and in a very precise and efficient way. You will find this idea of matching machining concepts to the different requirements of valve components throughout our production.
Which manufacturing technologies does Lisa use?
In Hohenwestedt, we have all manufacturing technologies for safety valves under one roof. Turning, honing, lapping, polishing, heat treatment, welding, electro-polishing and many more. Because of the automation throughout production, precision is part of every valve and, for example, generates surface qualities with which we exceed the tightness requirements of API 527.
How do you ensure the quality of the valves?
A Lisa safety valve passes 35 quality checks before delivery. We do not just check quality at the end of production, but build it in every manufacturing step, ensured by integrated quality management. Here you see the hydrostatic pressure test of inlet bodies with 1.5 times the rated pressure. Of course, 100% automated and applied to 100% of our valves. And with the same passion, we check all components of our safety valves.
What does the production process of a typical Lisa valve look like?
Most of our safety valves are manufactured in the so-called assemble-to-order process. This means all components, like bodies, bonnets or springs, are available here in stock. This means the valve can be assembled right away, which makes our delivery times short and reliable. At the moment, we have approximately 10 million euros worth of components here in our stock, which all were manufactured and checked according to the same high-quality standards.
How's the production process controlled?
A unique feature at Lisa is the very close link between production, logistics and our IT systems. From incoming goods through to shipping, every valve is controlled by our seamless SAP system. The close integration of these systems that I just pointed out enables us to trace all product and production-related data throughout the process chain with the serial number, from incoming goods, through checks during production to shipment. This data is at all times available for the customer. This documents our high production quality.
Lisa valves are also assembled from stock in Europe, Asia and America. How do you ensure uniform quality standards for all these valves?
We have a global quality system, Lisa, which, through global standards, ensures that all activities are aligned in manufacturing and assembly, and thus ensure our quality. In addition, we externally validate and certify processes, starting with product development and material management, where a lot of the quality management takes place before we even start production. In addition, we have the 35 quality checks that a safety valve has to pass as a standard.
How can the customer see these quality standards in his valve?
On the one hand side, we have a close integration of our production with SAP, which is our ERP system. Thus, we use this system to control our processes and also log the results of the quality checks in this system. Then we use this system to automatically generate the certificates, and other documents that the customer has specified in his order. They are either sent to the customer or can be accessed on our website.
There are very different requirements in complexity and delivery times from standard valves to large projects. How does that reflect in the laser supply chain?
In order to fulfill the delivery time and complexity demands of our customers, which indeed vary a lot, we establish different supply chains in the laser order service. We can offer these customer-oriented supply chains with short and reliable delivery times because most customer orders are off to a flying start at laser. In the assemble-to-order process, the production orders go right to the start of the assembly line because all components are already available in stock. Here, each valve gets its passport. With the barcode, we control all activities, starting with commissioning of the components from stock through assembly and testing activities, up to the final check. Each valve is assigned to one of 3 assembly lines. The valve is then assembled, set and checked at standardized workstations. A nameplate is generated in a laser machine and mounted before the corrosion protection coating is applied, and the valve finally reaches the final checkpoint.
Which benefit does the customer have from the laser supply chains?
Based on customer demand, we can deliver orders in days or hours, or send complex project orders with hundreds of valves in one shipment at the agreed date. The complex requirements of project orders with engineering, special documentation, or ITP requirements are taken care of in a reliable way at Laser. That's ultimately the goal of the supply chains and the production technology at Laser, to fulfill customer requirements on a consistently high level. Modern technology is our passion at Laser. In teamwork, we develop new products, processes and solutions which open up new possibilities in overpressure protection to our customers. Passion for technology starts with the training of our employees. Our apprentices are often amongst the best of their class, and with the Laser Academy, we invest in lifelong learning. In Hohenwestedt, we look forward to showing you how we turn passion for technology into quality built into every safety valve.
This is the disassembly process for the Brody Birotor Plus measuring unit. For this process, you'll need a rubber mallet, a wrench, an Allen wrench, a blocking stick, and 2 flathead screwdrivers. The first step is to remove the pulse output gear. To do this, you'll need to block the rotors with a blocking stick to prevent them from turning. Then use the Allen wrench to loosen the locking screw and locking washer and remove the gear. After removing the gear, set it aside. At this point, you can remove the blocking stick. You may need to use 2 flathead screwdrivers to pry the end plate loose. Wedge the screwdrivers between the end plate and the measuring unit. The end plates are slotted to aid removal. Once it is removed, set the end plate aside. On the opposite end of the measuring unit, you'll find the timing gears. Again, insert the blocking stick to stop the rotors from turning and loosen the lock nuts with the wrench. Remove the lock nuts and locking rings. Remove the blocking stick. Remove the timing gears. You may need to tap the gears with the rubber mallet to get them loose. Once they're removed, set the gears aside. Now use the Allen wrench to remove each of the 6 retaining screws from the end plate. Once the screws are removed, pop the end plate off. Again, use something to pry it loose if needed. Set the end plate aside. Finally, carefully pull the rotors free from the measuring unit. Your disassembly is complete.
In an environment where legislation and compliance requirements are forever changing, the accurate and reliable measurement of flare gas emissions has never been more important. Today, virtually every offshore production facility has flare gas meters installed to control mass balance, prevent leakage, and monitor CO2 emissions. The Fluenta flare gas meter system consists of a pair of transducers and a field computer with a maximum distance of 10 meters from the transducers. The meter is delivered with either a prefabricated spool piece or with latro flanges, which can be hot or cold tapped to an existing flare line. The meter is installed at the preferred 45 degrees diagonal angle to the pipe, with a full profile distance between the sensors for the best in accuracy and resolution. The sensors are retractable during operation, and the fact that there are no moving parts ensures that they are almost maintenance-free. In addition, every refinery, gas and chemical plant has at least one flare stack used for the same purpose as offshore platform installations. Flare measurement is an essential tool in controlling this process. The extreme high velocity of the flare gas can also cause damage to all intrusive parts of the instrument. To this end, Fluenta has a policy of not having any part of the sensors within the full flow profile of the flare line. The ultrasonic sensors on a Fluenta flare gas meter are always installed flush to the inner pipe wall, which gives the full flow profile measurement with the largest time resolution. This increases the accuracy at low velocity and also protects the sensors from high velocity. The Fluenta ultrasonic flare gas meter is based on the time of flight technique. Both transducers transmit and receive pulses, and the transit time is then calculated. When gas is flowing in the pipe, The pulse travelling against the flow takes longer to reach the opposite transducer than the pulse travelling with the flow. This time difference is used to calculate the flow in the flare line. Due to the unique chirp signal processing capability in the Fluenta flare gas meter, it can measure higher flow rates than any other ultrasonic flare gas meter. This technique detects exactly when the signal is received for both sensors. The electronics sort out the signals which reach the set acceptance level and calculate the flow and the density based on this. And such is its accuracy that the Fluenta flare gas meter is used by all major Norwegian oil and gas companies to help calculate taxes payable on CO2 emissions. An operator console can be installed in any computer and gives the user full access to the transmitter over the serial link. This operator console can be linked up to the system over TCP/IP to make the system available from wherever you have internet access. This also allows you to perform first-line service over the internet. The Fluenta flare gas meter is in operation on all continents and used by almost all the largest operators. So if you are looking for robustness, reliability and accuracy in your flare gas measurement, look no further than Fluenta.
Max Gertz from Disc Flow Corporation is joining me now. Max, this is a very exciting pump you've got here. Tell me the advantages of this when it comes to the oil and gas industry.
Well, what I can do better than most is I separate the produce water with no emulsification. So when you pump to a separator, you get 100% separation. And where the other pumps will emulsify, so therefore they have to send most of the product to a holding tank and let the oil settle to the top, and then they skim it off. And that costs time and money. With the disc flow, 100% separation because we don't emulsify, and that's the key, no emulsification. And the reason we don't emulsify is because we use the disc technology, the boundary layer viscous product. It's not a new concept, it goes back to 1850, but from 1850 up until the time I got involved in it, it was sitting on the shelf. And I was in aerospace and I took hold of it and made it into what it is today. It's a very unique technology. From the standpoint, I pump the abrasives where you would use a centrifugal, you overhaul it every 30, 60, 90, 120 days, minimum 10 years with disc flow, okay? And that's a lot of money in your pocket.
And tell me, who's using this in the oil and gas industry? What kind of company?
Shell, Chevron, BP, Statoil, Saudi Aramco, and that's why I'm here, is I want all the rest of these people to buy a product that's going to put money in their pocket. Okay.
And tell me, how has EDIPEC 2013 been for you?
Very, very good. I've had lots of genuine interest, and of course most people have never seen a disc pump before in their life. And although, you know, the professors that teach boundary layer in the universities didn't take time out and build one and really try it, because what I'm doing, they all claim, and we had 2 of them here today that said it's impossible, you can't do it. Well, I'm doing it, see? But also the unique feature of the disc flow is I can pump the hundreds of thousands of centipoise, where a centrifugal, once you get beyond 500 or 600 CPs, It's history. Now you have to go to a positive displacement device in order to pump the high viscosities. But disc flow will pump the same thing as you would use or buy a progressive cavity or a piston pump for. So it's unique from that standpoint where you don't have to run down to the nearest hardware store because you want to change from a light liquid to a heavy viscosity. You have it. We can do it. And so we have placed this pump with the major oil companies starting out in the United States. I've been in there for like Shell Oil. The first pumps I put in there over 30 years ago, still running, okay? Where my competitors, they overhaul them every 30, 60, 90 days. And that's money. And so they can take this money and go drill a new well. Say, okay?
Super. Thanks so much.
Okay, you're welcome.